All right, let's go over the lab. Yeah, it's data structures. We're going to have a lab every day.
I just said another day, another lab.
Another day, another lab.
I didn't mean to come off as harsh.
No, it's fine.
Sounds like we got 2 labs.
Maybe I should assign 2 of them. All right.
No.
In this lab, utilize the list interface to implement an array class. So, here's the list.hpp. I'll give you the class. Index of returns the index of some integer value. This really should be int list, but I'm just calling it list. Remove removes at the index, just like your previous lab. Insert. All right, now we're going to get a little tricky. Oh wow, excuse me. Insert the integer val at position POS. Wow, pause. Note that that will shift everything down. Do you all understand what I mean by that?
Shift to the left.
All right, let's do an example here.
Did you do that?
Anyone else have a question on this? Going once? Going twice? Yes?
For the thing you were about to do, the shifting to the left, didn't you already assign that?
Shifting to the left was remove. Now we're going to shift to the right.
Oh, no.
No. Sorry. Any questions on this? I'm about ready to erase. 1, 2, 3.
If we need it, we can watch the video.
Right. Good old videos.
Powers in the video.
Okay. So let's say you have the array 1, 4, 7, 12, 15, and you wish to insert at position 2 the value 5. That is so beautiful. All right, is that clear? Perfect. What that would mean is you'd still position 0, position 1, then the 2 would go there, and then everything afterwards. So this went right here. This went right here. And then that should be a 5. Ooh, that was bad. This went right there.
What? Wouldn't C++ just replace what was ever there?
That's not what I want you to do with the insert method.
We have to figure out how to
Is it going to hook that video?
Hmm?
We have to kind of figure out how to bump everything to the right so it doesn't just.
Correct. Mm-hmm.
How would you do that?
How would you do that? There's another problem here. Does anyone see it?
It changes the size of
Right. It
the array.
increases the size of the array. So now you got to take that into account as well.
I'm assuming you're using a ret somewhere.
You what?
Use a ret.
A ret? Okay, sure.
Just bring back Rover.
Yeah.
We haven't gotten to linked list yet.
Oh no.
We'll get to Rover.
Oh.
Rover will come back. But do you understand what I want you to do with this lab?
Yeah.
Oh, good.
What you want us to do? You want us to be able to do that?
All right, next is get retrieved element at a position pause. So if I do get of 0, that would be 1. Get of 1, 4. Get of 2, the 5. Get of 3, 7, 4, 5. Okay? Hopefully not too complicated. Good.
It's just accessing an array, isn't it?
Set actually sets the position.
Oh no.
So that, now this is what you were thinking about replace. So if we now do set, we'll do 3, 8. Now we would have 1, 4, 5, 8, 12, 15.
Replaces it.
That's easier.
Yeah, that's easier than insert, isn't it?
Wouldn't you just access the array?
Hmm?
Wouldn't you just access the array?
I'm not, yes, correct. Not trying to be complicated here.
Are you sure? No trick question?
I said I'm not trying to. That doesn't mean I'm succeeding. All right, equals. If you're past 2 lists, it returns if the two lists contain the same elements in the same order.
Okay.
Okay?
So wait a second then.
So in other words, back to this list, this guy and 1, 4, 5, 8, 12, 15
I'm missing a comma note from here.
are equal.
Yes.
All right?
Oh, so wait a second, before you write that.
8, comma 5, sorry, is not equal because they're in different order. Yes.
So if you swap back around 5 and 8 then, are those two also subsets of one another so they have the same elements in the same order?
Yes.
Okay. Okay, would you also consider it equal if, say, it was but a subset of one, but you cut off the end of the second one? Is that a would they still be equal in that regard? Can
If
they
you
have the same
delete a
elements in the
variable,
order?
if you delete a variable, they're not equal anymore. So if you take this 15 out, they're not equal
Right. Okay.
because they don't have the same elements.
Okay.
But you did touch base on an interesting way of testing equality.
Oh, another thing is, so in your set function here, you say to only return -1 if position is less than 0. But what if it's greater than the size of the array? Such as, say, the array is like of 6 positions.
Then you should return 0.
Okay, so you don't want it to like implement something to say set position 1000.
Yeah, no.
Okay.
Go to that. But you had a good subsequence question. And I'll see if y'all. If the first array is a subsequence of the second, and the second array is a subsequence of the first, are they equal?
Yeah.
Well,
Yes.
Yes.
If you really didn't want to write the code to test if everything was equal to each other, which would be silly, but I guess you could. We'll do a performance analysis and see who's better. All right, so that's it for this lab. Really, you have this list.hpp, and you declare another class, probably called int_array.cpp in HPP, that implements the list function, the list interface.
oh no.
Consider this code: array 10, 50, 34, 20, int array, new int of array in 5, and new array 2 is int array of the first one. So it's going to create a deep copy of each other. So what would be the output of this next line right here? It's important to understand. Are they equal to each other? Are they double equal to each other, I should say?
Yes.
One yes.
Wait.
Any maybes?
Is it asking about
To repeat the
pointer
question?
location, or is it asking about like what's inside?
That's my question to you. What is it?
Isn't it comparing the locations?
Mm-hmm. So then it would be,
Not equal.
yeah, so that would be false. Since the pointer locations are different, they're different objects. But what should this return?
True.
True. That should return true. Then if we have array 2 set position 2 to 10, aka that guy, then what should this return? False. But we set it back to 34 and then print it out again. What should it return?
True.
True. All right. Write your test cases, memory management. You can turn it in. Oh, by the way, I do have the webhook set up. So you can, for the autograder. So you can use the autograder now. And I've done this for lab 4, 5, and 7. Because those are the ones that really make sense for the autograder. Remember, after the first push, please wait 5 to 10 minutes for the autograder to get your repository, and then subsequent pushes should receive a grade. So push once, take a break, then push again, and it should start working.
It's now a good hook up the one.
How do we do the list?
Where's the webhook?
Isn't that
Steady.
under like settings or something?
Yeah, the webhook. Let's see. It's not here. There it is. So if you're in your GitHub repository, go to Settings, go to Webhooks, add the webhook. Put in my name, my password, Put in the payload. You want it to be JSON. Make sure it's JSON. Always make sure it's JSON.
What if it's XML?
Then it will not work.
Oh.
It has to be JSON.
Is there a secret?
No, there's no secret.
No.
Just the push event. Don't send me everything. And have the webhook.
Push shipping ahead.
Whoo! All right. And then that would actually set up the webhook. I'm not going to do that for my course repo. Let's see. Let's go look at the code. Because I have been nice to you. I gave you a make file, gave you a source directory, I even gave you a test directory. I know. I am so nice.
For every lab or no?
Probably not. So, huh?
Seriously?
I did for this one.
And you did it before too.
I know. Wasn't that nice of me?
Keep doing it.
You think I would?
Can you,
No.
you think we're able to create a template from it and use it for labs?
Yes, you can. If once I stop giving you code, you can copy pasta from previous labs as a template for new labs. Please do that.
Sadness won't occur.
So here we have that class list. Notice I've just copy and pasted that code from the slide. Notice that there's no list.cpp. There's int-array CPP, int-array HPP, and list.hpp in the main file. Let's go look at int-array.hpp. Well, it looks like you're going to have to fill that out. Have fun with that. And then you have CPP. Oh, look. You're going to fill that guy out as well. But at least gave you the two files to start editing. And then you can look inside of main. It has nothing in here. That's fine. Just getting y'all used to the environment. And then inside of test, I have constructor test, an equal test, a get test, an index of test, an insert test, and a set test. So if there's something that's not making sense, like the constructor test, oh, I haven't even filled that out. Great. So, which is beautiful, because now you can just type make constructor dash test, hit enter, it compiles and run the test. It says it's okay because there's no test cases in it. Please note that I am assuming you're using the int-array class from your previous lab and appending it to work with the new code. So make sure you, once you're done with lab 5, you copy pasta the code to lab 7 for your int-array and start working from there.
Oh boy.
Yes, Dr. West.
Yes, Dr. West. Was it Dr. Strangelove?
What do they call those doctors?
And how I learned to love the bomb?
Does he have an odd way of, loving his wife?
He has a strange love of things, that's for sure.
Oh.
All right. Any questions about this lab? No questions?
I'm guessing we're covering more material today?
No, that's it.
Ooh. Can I talk to you then?
You can always talk to me.
It just
Because I
depends
need a
if you'll
few things from
listen.
you, not related to data structures.
No.
All right, anyway, yeah, we'll talk. Any other questions about what I've gone over today? Yeah, you have a whole hour and 50 minutes. Wow.
Good. We need it.
By the way, please start thinking of your lab. You're not going to be able to do it the weekend before it's due.
Wait, you mean project?
Project, sorry.
So are you sure?
Start thinking about your project. Your-
Lab 5 and 6 due Wednesday?
Yes.
Try. I need to check.
This is a train.
I
It
tried.
stops for no one.
Okay.
All right, let me go ahead and stop the recording.